Hi, this is Elliot Haspel and welcome to another edition of Best Practices Weekly. Today we're going to be talking about ways to make math relevant to elementary school students. And this is drawn from work done by the Australian Association of Mathematics Teachers, where a professor at an Australian university surveyed different researchers' methods and findings about making math relevant, and then summarized them in detail. And the idea here is that actually for elementary school students, we often try to make math relevant and engaging to them by tying it to real-world examples, how you would use this math in the real world, but it actually turns out to often be not as useful as we would think it would be, for two reasons. First is that students just not that interested in some of these real-world applications yet. So the example the professor gives is that if you think about using area to carpet a floor is like a common type of word problem that students might encounter. And students actually don't care about carpeting floor when they're in third grade. And the second problem is that because the math is still pretty low level in elementary school, the real-world examples become so sanitized as to lose all relevance. So that carpeting the floor example, the actual process of carpeting a floor is much more complicated than what would be put into a one-paragraph word problem about using the formula to find area. So instead, the professor suggests, again drawing from other research, that there are different models we can potentially use that does make math very relevant and engaging to elementary kids. So the first one of these is to have what's known as an experientially real cycle, and this is where we put a problem in front of students that they're really going to wrestle with, and the problem might not have a lot of real-world applicability. So an example that's given from the Netherlands is seeing what happens when you put everyone's name on grid paper and then talking about the patterns that emerge. And there's a cycle here of exploring, so really letting kids think about what's going on, what are the patterns looking like, explaining, being able to put what they're noticing into mathematical terms. So again, if the objective here is around patterns, being able to speak about the patterns in mathematical ways. Reflecting, so as a group in the pairs and individually really thinking about what they've learned about patterns from this experience. And then recording, which is some form of drawing, modeling, in some way being held accountable to put their thoughts on paper about what they've learned. And so this cycle can be a way that really engages students in what is a short-term task, but because you're going through an experience and you're having students wrestle with the ideas, it actually becomes very relevant to them in that moment, even if to us, we think that like looking at patterns of names on grid paper might not actually be that interesting. Another model that the professor talks about is this idea of a planning matrix that combines purposeful activities with meaningful context. And this is sort of a variation on the theme of the first idea. And by purposeful activities, these are things that are very much relevant to kids' lives. So solving an actual real problem, or planning an event, or designing or constructing something. These are things that, to someone who is 7 or 10 or 12, actually is very relevant. And then combining those with different contexts that's meaningful to those kids' lives. Things like the classroom, things like sports, things like fundraising. These are things that students interact with on a regular basis in their lives. An example the professor gives is if you combine planning an event with fundraising, what you might actually end up with is that the students are involved in planning some sort of charity fundraiser for the school or for a charity of their choice. And that project can bring in lots of different math concepts and lots of different math skills, but you're doing it all under the umbrella of this project that's extremely relevant and meaningful to the students themselves. The last two ideas the professor summarizes are more straightforward. One is making sure that you're incorporating student interests consistently, which means giving students surveys pretty regularly so you know what are their interests, what are the meaningful contexts for them, what is the purposeful activities for them, what are they particularly interested in, and what would be engaging to them. And then lastly, integrating other subjects into math. So bringing in art, bringing in science, bringing in social studies, which are things that students will often engage with and feel like are more relevant than math, which can sometimes feel abstract, and so integrating the two can again increase the relevancy. I think the biggest takeaway here is that we have to get away from the idea of the only way to make math relevant to kids is to tie it to real-world applications, and that actually we can create relevant situations for students, especially elementary school students, by thinking about what for their lives is relevant and what for their lives is meaningful. And if we do this, we can really overcome those barriers and make math something that students are really very engaged with and really want to do well with. Thanks, and we'll talk again soon.